For decades, we assumed that dinosaurs were just in the wrong place at the wrong time. But a brand new research published in the Science Advances revealed something far more wild. The dinosaurs were not just unlucky, they were cosmically doomed. Scientists just identified the dinosaur killer asteroid and the cosmic coincidences that wiped out all the dinosaurs from the planet Earth. Around 66 million years ago, a 10-kilometer asteroid slammed into the Earth, ending the reign of the dinosaurs. But this new analysis reveals that dinosaurs were not just killed by an impact. They were victims of a statistical impossibility. From slipping past Jupiter's gravitational shield to striking Earth at the worst possible angle and season. This deep dive explores how a rare carbonaceous ornament, cometrite, from the outer solar system rewrites everything we knew about the Cretaceous Paleogene KPG extinction event. Now, geologists are analyzing nickel isotopes in Denmark, Spain, and Italy. And guess what? They have uncovered the true culprit behind the Earth's deadliest day. So let's find out if these new evidences rewrite history. With a force of 10 billion atomic bombs, it triggered global wildfires, mega tsunamis, ocean acidification, and a nuclear winter that wiped out 75% of all living species. Now, scientists are analyzing rock samples across the Europe, and they have identified the exact origin of this world ender. It wasn't your average asteroid. It was an extraordinary rare cosmic vagrant from the darker outer reaches of the solar system, a rock that slipped past the Jupiter's gravity, hit the Earth at the absolute worst angle during the worst possible season in the worst target spot on the planet. If even one of these parameters had been slightly different, dinosaurs might still be walking the Earth today. Here's the true story of how a series of impossible coincidences brought down an empire. But before we look at the new discovery, let me show you just how stacked the odds were against the dinosaurs. Now first consider where it hit. The asteroid struck in the modern-day Mexico. Less than 13% of Earth's surface contained the specific combination of hydrocarbons and sulfur-rich rocks found in exact that marine shelf. Had that rock hit deeper in ocean water or granite continents, which are 87% of the planet, the vaporized atmospheric suit would have been dramatically lower and the mass extinction likely wouldn't happened. It means if it had slammed at some other spot, leaving behind this 13% of Earth's surface, the effects might have been milder. Second was the angle. Numerical simulations show that asteroid struck at sharp 60-degree angle, and this was the optimal trajectory to blast maximum rock debris straight into the stratosphere. And the third, the season. Fossilized remains from the site reveal that the strike happened during the northern hemisphere spring. This was the peak growing and breeding season for the northern fauna, ensuring maximum disruption to the food web right when ecosystems were most vulnerable. That's the three catastrophic coincidences. But now geologists have uncovered a fourth coincidence, and it's the biggest one yet. Around the world, there is a thin dark line of clay buried in rock strata. This is the Cretaceous Paleogene KPG boundary, the geological tombstone of dinosaurs. A team of researchers led by the geologist Philip Claes at the Vrije Universiteit Brussels in Belgium collected samples from the 5 key KPG locations, one in the Denmark, one in Spain, and 3 in Italy. They were hunting for nickel isotopes. Nickel is far more abundant in primitive meteorites than in Earth's crust, and different subclasses of space rocks leave distinct chemical fingerprints based on their ratio of nickel isotopes. After isolating and purifying the nickel from the boundary clay and comparing it to the 11 different meteorites, the data pointed out directly to a culprit: carbonaceous ornaments, cometrites. Now, to understand why this is a massive deal, we need to talk about a space rock geography. Most asteroids that hit Earth come from the inner asteroid belt between Mars and Jupiter, and these are usually silicate or stony meteorites. Only about 5% of meteorites reaching Earth belong to this carbonaceous chondrite family. primitive rocks formed in the freezing outer solar system beyond Jupiter. Within that 5% of this class makes up a tiny fraction of a fraction. Now normally Jupiter acts as our solar system's gravitational goalie. Its massive gravity traps outer solar debris or slingshot it out into deep space. Yet somehow 66 million years ago, a colossal 6-mile wide CO class world ender slipped past its gravitational net and migrated all the way into the inner solar system and landed dead center on the Earth. As Dr. Clays put it, being impacted by such a rare distant projectile really underscores how cosmically doomed the dinosaurs were. Identifying the impactor doesn't just trace its origin, it changes our understanding of the extinction event itself. For years, many scientists believed that sulfur from the asteroid itself played a massive role in creating the acid rain or cooling the atmosphere. But the CO chondrites are inherently dry and volatile. Compared to other carbonaceous meteorites, CO rocks carry significantly lower levels of volatile elements like carbon, zinc, water, and especially sulfur. This chemical realization proves that asteroid-derived sulfur was not the smoking gun. Instead, the global darkness that choked out the photosynthesis for years was driven primarily by two things: the vaporized target rocks from the Mexican marine bed and the billions of tons of fine silicate dust ejected directly into the upper atmosphere by the kinetic energy of the impact. And when you add up all the pieces, like a rare outer system visitor, CO class meteorite, with only 5% chances of coming here. Second, bypassing Jupiter gravitational wear. It's a huge one. Third, striking a target rich in hydrocarbon. Top 13% worst location on Earth. Fourth, hitting a 60-degree high debris angle. And fifth, northern hemisphere spring season. It becomes clear the demise of the dinosaurs were a 1 in a billion cosmic tragedy. But their terrible luck cleared the evolutionary stage for small mammals to survive, adapt, and eventually evolve into us. Now, today we don't have to rely on luck. Missions like NASA's DART and other similar programs have proven that we can redirect the incoming asteroids, but discovering that an outer solar system rogue was responsible serves as a stark reminder that deep space is unpredictable. This story reminds us how fragile a planetary life is. One rare rock from the outer dark, perfect timing and place, and boom, game over even for the giants. Now, what do you think? Could we survive something similar today? Drop your thoughts in the comments. Thanks for watching the video. Also share this video with your friends who love dinosaurs, and I will see you in the next video.